All right, so we left off. We are covering object-oriented programming, and so far, we left off with just these kind of some very basic ideas of like, here's a class. When you call the class, you can create new instances of that, particular class of object. So far, we're creating instances. But and we just barely talked about methods, okay? So methods are functions, but they're different from regular old functions in that they are functions that are part of the class definition. The function or the method belongs to the class definition. So we've been working on this time class, okay? And so far, what we had was we just had a blank definition of the class time. Right now, there's nothing in there other than this docstring. I have this separate function that takes an instance of a time class object and it prints it out to the screen. Okay, and we can run it. So I create an instance of the time class object by doing start is equal to time parentheses. I define attributes .hour, .minute, .second, and then I can call print time on that time class, that object, that start object, and it prints out 9:45. Okay, so that's what we have. And all I'm going to do to create the method is I'm going to just copy and paste this definition of print time into the definition of the time class. And when I do this, this now creates a method called print time that belongs to the time class object. So here, to call the method, I'm going to create an instance of the time class object. I'm going to call it start again. Hour, minute, second is going to be 9:45:0. And then to get it to execute, I can call the function by its full name, which is capital T time dot print time, and I can put in the object start here. Okay. This is uncommon though. Okay, we don't really use this. The more common way to call a function or a method is you use the object. In our case, our object is called start because we created an instance of the time class object. And then now that we have that object start, I'm going to call the method using the dot notation. It's going to be start dot, and I call the method print underscore time. I don't even have to pass any arguments into it. Okay. And when I do this, it calls the method here, okay? And it prints it out. And that's what it is. When you call a method from the object itself, you'll notice the definition of print time takes in an argument called time. And normally, if you call a function that requires an argument and you don't pass an argument, it results in an error. But here, I called the function or I called the method without passing an argument. And that's because the object itself, when you call the method or from the object itself is always passed as the subject of the method. It always gets passed in as the first argument. So print underscore time accepts an argument called time, and that object called start will get passed in as that argument. And it gets executed here, okay? So the subject always gets passed to the method as the first argument. And so the object start gets passed in as print time, okay? Now by convention, when you create these methods, okay, here I have defined print time on time. By convention, we call that argument self, okay? So we would define our method kind of like this. So instead of calling print time on time, we would call print time on self, okay? And therefore, the object itself gets passed in to the method. And so we are going to, I've just taken the same definition up here, and instead of saying time.hour, time.minute, time.second, okay, it's just going to be self.hour, self.minute, self.second, okay? So that's the convention. The first argument of a method is called self, and so when you see read other people's code where they're using objects and class definitions and things like that, you're frequently going to see this word self there. Okay, and the idea is that when you call a method, you're applying the function to itself. Okay, and then and so I have the method print time there, and then also I'm going to add the other method time to int, which is going to take itself as an argument, and it's going to turn whatever time it is into the number of seconds after midnight, okay? By doing self.hour times 60 plus the number of minutes, and then the number of minutes times 60 times the number of seconds, self.seconds, and return the number of seconds here, okay? So now I'm going to create another instance of the time class object. Now that I have a new definition of the time class, we're going to call it start.hour. And so I can call start.printTime, and it prints out 9:45. I can do start.time-to-int, and again, the object itself gets passed in as the first argument self, and so 9:45 is 35,100 seconds after midnight. Okay, so that's kind of the key thing when defining methods is the object itself always gets passed in as the first argument, and by convention we call that first argument self. Over here we have this other function that will take the number of integers or number of seconds and return a time thing. So this is going to be int to time. Now this can't be made a method of the time object because the argument of this function is an integer value of seconds, okay? And so basically we're going to take some integer like 35,100 and we want to convert it into a time, and we can't invoke this method on just integer class object or something like that. Okay. All right. So let's expand, and we will just add another method to our definition of the time class object. Okay. So here I'm adding one more method. So I have the same methods from before: print_time, time to int, and now I'm going to add another method. This is going to be increment, and this method takes in two arguments. Okay, it's going to take in itself. So always, even if you don't use self, if you define a method or a function inside a class definition, the first argument is always going to be itself. Okay, it's always going to get passed in as itself. So if you want to take something else in, you still have to put self and then something else there. Okay, or just whatever you want to call it. But the object itself is always passed in as the first argument. So here we want to take time object, and we want to increment it some number of seconds. So here we're going to define this method increment. The argument will be self and the number of seconds to increment by, and we're going to invoke self.time-to-int. So we're going to call this method to get however many seconds there are here on our current time, and then we're going to add it to the number of seconds here. Okay, and then once we get the total number of seconds, once we add those two things together, we will call this function int to time, which exists outside of the class definition. Okay, so this has to be defined somewhere like in the global environment or something, but we're going to call that function, which returns a time class object, and that will be what this function returns. Okay, does that feel okay? There's kind of a lot going on. It's just 3 lines here. Okay, one to define the function, and then basically 2 lines here. But it's kind of a lot because one line is calling a different method from the class definition, and then the other line is calling a function that exists outside the class definition. But we'll try this out. So right now we have our start time, 9:45. We'll print it out. That's 9:45. And let's say I want to increment it 1,337 seconds. Okay, 1,337 seconds is like 22 minutes. I don't know. Okay. 22 minutes and 17 seconds. So 9:45 plus 22 minutes gives me to 10:07:17. So start.increment 1337 returns a new object. We're going to call that called end. And then I can, so if I just said, hey, what is end? It's just a time object, but if I want to see what it is, I do end.printtime, and it prints out 10:07:17. Okay. Start print time is still going to be 9:45, right? So this method here increments and returns a new time, doesn't actually change the value of self. Okay. All right. If you try to pass in multiple arguments here, so if I do start.increment 1337 and 460, here, the error that you're going to get, okay, it says time.increment takes 2 positional arguments, but 3 were given. And this might feel confusing because when you look at it, it only looks like 2 arguments are going here. But remember, the object itself is always going to be passed in as the first argument. And so in this definition, this function, the method takes in self and seconds. There's no third object here. And what we are passing here is we're passing self, 1337, and 460. So we are passing it 3 arguments. Okay? Even though it only looks like 2, the self is always passed in as the first argument. So we are indeed passing 3 arguments into this method. Okay. All right. Here, sometimes you want to have your object interact with another object, okay? And so we could create a method called isAfter, okay? IsAfter is going to do a check to see if one time takes place after another time, okay? And so what this is going to do is it's going to take two time class objects and do a comparison between them, okay? And we want to do this. And so when you have, if you want your object to interact with another object, the convention, okay, is to call the other object other in the definition. So here, remember, self is always passed in as the first thing. So this definition, it's just going to return whether one thing is after the other. Okay, so we're going to do is after self versus other. Okay, so it's going to, the way you call it is going to be like start is after some other time. Okay, and the way we're going to do this is we're going to convert our current time into integers. We'll convert the other time into integers. Okay, and so we invoke the method time to int on the self, and then we're assuming the other object is also a time class object, so we're going to invoke the same method time to int on the other object. So we're going to do other time to int. So we have an integer over here, an integer over here. We have a greater than sign to do the comparison, and when you have a greater than sign or less than a comparison operator, it's going to just return either a true or false. Okay. And that's what it's going to return. So it's just going to return the result of this comparison, which will either be a true or a false. So we invoke the method time to int on itself, time to int on the other time class object, and we're going to return the result of that comparison. Does that feel okay? All right, so let's try that out. Here we're going to create start time. Okay, start time is 9:45. I'm going to increment start time to create my end time. End time is 10:07:17, and then we're going to ask end is the end time 10:07:17, is that after the start time? And so internally what it's doing, so that returns true, and internally what it's doing here is it's doing end dot time to int, okay, and it's getting this number 36,437, and it's doing start dot time to int, and it's 35,100, and it's saying is 36,437 greater than 35,100, and that comes back true. So end is after start, that's true. Is start is after end, that's going to come back as false. let me give you, I gotta pull this up, view quiz answer. Okay, week 7, Friday, first answer is the letter E. E as in elephant, E. Okay, so far what we've been doing, our class definition just has these methods in it, but every time I've been creating an instance of the time class object, I've called it start, and then I've been adding these attributes, .hour, .minute, .second, and I've just been kind of manually adding these things, okay? There is a special method called the init method, okay? And it's called double under init or dunder init, okay? Because it's double underscore init underscore, and it stands for initialization, okay? And this is going to get invoked. The init method is invoked anytime you create an instance of a class object. So anytime I want to create a time class object, if I want to create an instance of that, the init method is going to get invoked. So here I'm going to define my time class. Again, I have all the same methods as before, but I'm now adding this initialization method, okay? And so what this is going to do is that the initialization method takes in 3 arguments in addition to itself, okay? So again, all methods in the class definition, the self is always the first argument. Always, always, always. Always the first argument. But we're going to take in 3 additional arguments, okay? And those arguments will be the hour, minute, second, and I'm giving it default values of 0, 0, 0, okay? So when I call it, it will initialize to having the time, 0, 0, 0 or midnight, okay? And all we're doing is we're going to just take in those values that gets passed in, and we're going to set it to self.hour, self.minute, and self.second. So all we're going to do is we're just going to assign the values that get passed into itself, and this will get invoked every time we call the create an instance of a time class object. All right, so now I can just call create instance of midnight of time with no values, okay, and that will pass in 0, 0, 0, and that will be midnight. And so if I ask what is midnight, now it's a time class object with the time 0, 0, 0, okay. Here, if I pass in 9, it will get passed in as the first argument that comes after self. So that will just be hour is 9. So this will be 9 a.m. Okay. Okay. I could create the time 9:45 by doing capital T time 9, 45. 9 gets passed in as the hour. 45 gets passed in as the minute. And so now my new time will be 9:45. Okay. If you ask, hey, what is this object in new time? It still comes out as, an instance of the time class object. And if I say, hey, print new time, it gives us kind of a slightly longer description, okay? It says it's still just a time class object located at this memory location. It gives us kind of the full memory location, but same idea. This is not legible to us as humans, okay? But we can always kind of invoke the print time method on itself, and we will get it back 9:45. We can also just kind of extract any of the attributes, like what is the .hour attribute, and it says the .hour attribute is 9. Okay, so that's where we are right now. So we have the dunder init, okay, the init method that will get invoked every time we create an instance of this class definition. The another special method is the dunder string method. Okay, the double underscore string method is a special method And this gets invoked anytime you call print. Okay? Anytime you call print on an object, it's going to invoke the double underscore string method. Okay? Now, so far, what we've been doing is we've been calling dot print time, a method within the class definition, so that we can see the time. All I'm going to do, okay, is I'm going to just change the name of print time into double underscore string. Okay? So it's the exact same method. It's the exact same function definition, and I'm just going to change it to double underscore string, and then instead of printing, I'm going to return it. Okay, so rather than printing this to the thing, I return this value. I return a string. And now print is going to invoke the string method, and then the string method returns the string representation of the object, which is 094500, and then it will print it. Okay, so I take the exact same method of the function definition of print time, I just rename it to double underscore string, and then instead of printing out something to the screen, I return that string object. So this is the key, is that we use return rather than print. So now, if I call new time here, okay, new time is still going to be this time object, but if I call print on it, it invokes the string method, and we get 945. Okay. If I ask give me the string representation of this, this will also return the string representation of 0945 here. Okay, and it's similar to asking the computer print the number 9 versus give me the string representation of 9, which basically puts the number 9 in quotes here. Okay, but basically this is the preferred method, okay, or preferred way to have your objects print out. So you use the double underscore string method, and then now it will get invoked anytime you call print or ask for a string representation of the object. Okay, rather than, the old way was new time.print time, which can be a little bit annoying. Okay, there are even more special dunder methods, okay, and they have special uses. And so one of them is the dunder add method, okay, double underscore add. And this, when you use this, it's called operator overloading, because we have this addition operator on our computer. We have the plus operator. And basically what we're doing is we're going to give this addition operator additional functionality. We're like overloading it with additional functionality. And basically what this dunder add method does is it will get invoked anytime it sees the plus operator, okay? And, the plus operator takes a value, in front of the plus operator and a value after the plus operator. And so we're assuming we have these two objects. And so when we use when we create a definition using the dunder add method, okay, it's going to take in two objects, the self and the other. So kind of like the is after comparison, we have the dunder add. It's going to take itself, and so the idea here is you have the self, you have the plus sign, and you have the other object. Okay, so the thing that comes before the plus sign we are assuming is the self, and the thing that comes after the plus sign will be the other object. So self comma other it's going to get invoked when you see a self plus. And so basically if we have two time objects, we want to say like, hey, can I take the time 9:45 and add the time 1 hour and 20 minutes or something like that? Okay, and what will that take me to? So 1 hour and 20 minutes after 9:45 will be what, 11:05 or something like that? That's kind of what we want it to do. And And so the way we're going to add 2 times is we are going to invoke time to int on ourself. We're going to invoke the time to int on the other time object that gets passed. Okay, and then we add those 2 together, and that will give us the total number of seconds after midnight. So if we have 9:45 is 35,100 seconds after midnight, and an hour and 20 is, I don't know, something else, okay? We're going to take those 4,800 or something. We're going to take those 2 things, add them together. We get, what, 39,900 seconds. And then we're going to call this function int to time back on the total number of seconds. So it's a lot like this, okay? A lot like the increment, except the thing that we're adding is not just the number of seconds, but it's another time object, and we have to convert that other time object into this. And then we're going to return whatever time that returns. So so here we have 9:45, and duration is an hour 35. And I could call, I can say print start, and that's 9:45. Print duration, okay, 1:35. And so if I do start dot plus duration, okay, it didn't give us an error, but it just gives me back a time object, which is not helpful to me. But I can say, hey, print this out. Print out start plus duration. So 9:45 plus an hour 35 is 11:20, okay? If I change this to 1 hour and 20, it works, 11:05, okay? So that seems like it's working, okay? What if, though, I wanted to just kind of increment it and add 1,337 seconds, okay? If I try to do this, I get back an error, okay? Because it sees the 1,337 seconds, and it sees the plus sign, so it's invoking the dunder add method, and it says the integer 1,337, which is getting passed in here as the other, doesn't have this method time to int. Okay, so it doesn't know what to do, and it errors out. Okay, attribute error. It says the integer 1,337. I can't do this thing that you're asking me to do here. Okay, so so we can have something to check what kind of object it is, because this plus operator, it would be nice if we could add time objects. If I could do 9:45 plus an hour 20, like a time object, or it could also be nice if I just did 9:45 plus 1,000 seconds, and it would be nice if we could do both of those types of things. So so we can have 2 functions, okay, and we will invoke one or the other based on the object that gets passed here. Okay, so so this will be type-based dispatch. Let me go ahead and give you your second answer. Second answer today is the letter C. C as in cat. C as in cat. Okay. So the previous definition of add, double underscore add, allowed us to add 2 time objects, but we might also want the option to add integers as well. And we can use type-based dispatch to call different methods based on the type of input. And so to do this, we use this function called isInstance, okay? And that will see if an object is an instance of a particular class. So here I'm going to have this function, the dunder add self.other, and we're going to check to see if the other object is an instance of the time class object. Okay, if it is, we're going to use the add time function. Okay, which will do it's what I previously had as the add method. Okay. Which, so we're going to take the other thing, do a conversion to a time to int, the self time to int, we'll add those 2 together for the total number of seconds, and then we're going to return integer to time here, okay? However, if the other thing is not, okay, so if it's not an instance of the time, we're going to assume that it's like an integer, okay? So otherwise, else, okay, then invoke the other method, self.incrementOther, okay? So we got self.addTimeOther, which assumes the other thing's a time object, or we're going to invoke self.incrementOther. IncrementOther assumes the other object is already basically an integer number of seconds here. So, so then in that case, we're not going to invoke .timeToInt there. We'll just take the number of seconds. We'll invoke timeToInt on itself, add that to the number of seconds, and then we will return the total number of seconds there. Okay, is this feeling okay? I don't know if I'm covering too much too quickly, or if this is, I'm just trying to kind of build up our class definition, and kind of a lot of the power in Python comes from these double underscore methods, okay? And so double underscore add allows us to, use that plus operator. We want to be able to use the plus operator both for time objects and integer objects. And so we're using the isInstance to see what kind of class object it is, and we invoke, based on that, we're either going to invoke the addTime method or the increment method. Okay, so let's test this out. I have my start time, 9:45. My duration is 1 hour 35. Okay, can I do start plus duration and get something? All right, that works, 11:20. Can I do start plus 1,337? That also works. Okay, now I'm getting 10:07:17. Okay. I can do start.addTime duration. I can try that. Okay. And that works, okay? So start.addTime, instead of start plus duration, I can call it addTime, or I could do start.increment 1,337, and that's working. Okay. So far, everything seems to be good, okay? Our method, however, is not commutative, okay? And so if I tried to do 1,337, the integer plus a time, we get back an error, okay? It says we're trying to add an integer with a time, and it doesn't know how to do this, okay? So we can do start plus 1,337, but I can't do 1,337 plus the start time, okay? And so if you wanted to be able to do something like this, we can do this by calling right-hand add, okay, radd. So define radd, and in this case, we have a self.other. So with radd, with add, it assumes the first object is the self, and the object that comes after the plus sign is the other. And then with radd, it assumes the object coming after the plus sign is the self, and the object before the plus sign is the other. Okay, so all we're saying is that, okay, if it's in a situation like that, do radd, and then just return self add other, and then and so this will invoke the dunder add method, which will do a check for what kind of instance it is, if it's a time class object or if it's an integer, and then it will invoke this. Okay. Now, if there's a conflict, if you have object A plus object B, and object A has a add method and object B has a radd method, the priority is it's going to do the add first. Okay, it's going to do add. And then if it can't figure out how to do the add, then it looks for the radd, okay? So anyway, all we're doing is we're just expanding our definition by just kind of expanding our class definition using dunder add and dunder radd. Okay, so here I've got 9:45, the duration 1:35. I can do start plus the duration. I can do start plus 13:37, and now I can do 13:37 plus start. And this does not result in an error because now this is invoking the right-hand add. The right-hand add. Okay, and so this, I think, this is one of the coolest features of Python, okay? Python's object-oriented system is that some of these functions are, some of the functions have polymorphism, okay? Meaning, now that I have this dunder add method created, okay? Now that my object has the double underscore add method, I can use other functions that do addition-like operations, okay? So, for example, I'm going to create T1, okay, which will be an hour 20, T2 an hour 40, and T3 an hour 30, okay? And then I'm going to put T1, T2, and T3 into a list. And then I'm going to call sum on this list, okay? I never told Python how to do a sum with time class objects. I never told it, like, because sum can take in like some arbitrary number of objects, and normally we give it integers and it adds them all up, or floats and it adds them all up, okay? However, because I've used the double underscore add thing, Python is smart enough to just say, oh, when you do a sum, just use that double underscore add method and add all of these things together, okay? So here, if I do an hour 20 plus an hour 40 plus an hour 30, that's going to be what, 4 hours and 30 minutes? And it works, okay? So you guys aren't blown away, but this is really cool, okay? This is like, if you try to implement something like this in something not Python, this is like way more complicated because you have to kind of like teach like how the sum function should work for these other kinds of objects and stuff like that, okay? So here, you know, I mean, even though here I have the plus operator, okay, and I'm doing T1 plus T2 plus T3 plus T3, okay, it's going to figure out how to add all of these things together, okay? Even though the add method by itself only takes in 2 arguments, okay, I have this, you know, we're accustomed to just being able to add like 3 plus 5 plus 7 plus 8 or something, and we know how this works in our head, okay? But again, Python just says, oh yeah, the plus operator, even though like I've got only kind of 2 objects, the dunder add method only takes in 2 objects, it can still do something like adding a sequence like this, and it works exactly as we would think, right? 4:30 is 1, 2, and 3 adds up to 4 minutes and 30 seconds. And if I add T3 again, which is another hour 30, that takes me to 6 hours. Okay, here L1 is going to be, it's just L1, you know, it's hard to kind of read this, okay? It's just 4 time class objects right now, okay? T1, 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 and T2. What is that? T1 is an hour and 20, so I've got 3 of those, so that's 4 hours. T2 is an hour 40, so that's 5 hours and 40 minutes. I can just take the list, I can do sum on the list and print that out, 5 hours and 40 minutes, okay? Here, again, I've taught underscore add how to handle both a mix of integers and time objects, okay? So I'm gonna do T1, T2 or something, okay? This is gonna come in as 30 hours though, okay? Oh wait, no. 30 seconds, sorry. It comes in as 30 seconds because the integers are treated as seconds. And so when I do T1, 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 T2, comma 30, it's gonna treat that as 30 seconds. And again, I'm mixing data types into this list, and Python has figured it all out, okay, when I call the sum here. So that's cool, right? That's cool. Okay. Again, you can kind of add attributes to objects at any time. If you have objects of the same type that don't have the same attributes, it can cause problems, right? And so basically, what you should, like, even though in the beginning, the way we were using the class objects is that we were creating like a new time, and then I would do like start.hour, start.minute, start.seconds, and adding attributes like this. So this is allowed and this is legal in Python, but it is not recommended, okay? The recommended method is that any of the attributes that will exist inside your class object should be part of your dunder init, okay? And that you shouldn't be adding these additional attributes on the fly later. So you are allowed to do it. It's not going to error out, but it can be confusing to do it that way. So the recommended method is to create your double underscore init. All of the attributes are created there, and you don't do anything, kind of things like that. Okay, you can call vars on any kind of instance, and it will kind of list off any of the attributes that do exist within an object. So vars on start will give you hour, minute, second, or things like that. Okay, and then if you're using VS Code, you can also call variables, and you have all of these different things, and you'll notice these the representation in the values thing is it gives you the string representation, which makes it a lot easier to read, right? You can always kind of look at these things here. Okay. All right, that's all I have for you guys today. I gave you 2 answers, is that right? Okay, all right, third answer today is the letter B. B as in bear is your third answer. And we'll wrap things up here. This is kind of a big notebook and a heavy notebook with lots of stuff, but I recommend you work through it and review it. There's a lot of good stuff in here, okay, regarding the object-oriented system in Python. We'll keep looking at some more object-oriented stuff, but we'll go ahead and end there. All right, see you guys later.